Hello and welcome back. Last week we added in the ability for the player to fire a missile. This week we'll be making that missile destroy any asteroid it collides with and spawn a new one away from the player. As usual, let's check that we have the previous code running by typing cargo run. You should see the following, where you can control the spaceship and fire missiles, but those missiles simply pass through the asteroid without changing anything. If you don't see this code, then you can use git checkout tutorial 10 to get that code. Instructions on where to find the code are in the comments below. The first thing we want to do is navigate to the missile.rs file and scroll down to the bottom. Then we will create a new empty struct called Missile Striker. Underneath this, we will implement the system as we have done before. As we normally do with these system implementations, we will set the system data variable by calling the ECS storage. We will fetch the right storage for the component types of position, renderable, missile, asteroid, player, and finally a reference to all of the entities. Then we'll create our run function. This will be run by the dispatcher. This is the same as the previous ones we've made for missile mover and asteroid mover, for example. First, we break out the components in system data using a grouped set of variable names. Next up, we're going to loop through every missile object. We do that by running a for loop, getting every entity that is a missile and fetching the position and entity. We call those missile pos and missile entity. Inside this for loop, we're going to do the same, but for each asteroid. This will probably seem very similar to the asteroid collider implementation that we did in a previous tutorial, and that's because it is. The relevant variables created from this join are asteroid pos, asteroid rend, and asteroid entity. Inside these two nested for loops, we'll first calculate the distance in x-coordinates by subtracting one from the other and taking the absolute value. We will call this diff(x). And we will do the same for the y component, storing this as diff(y). Finally, we will calculate the hypotenuse by multiplying diff(x) by itself and diff(y) by itself, then adding the two together, and finally taking the square root of this sum. And now we will check to see if the hypotenuse, which is the difference between our objects, is less than the output width of the object, taken from the renderable component of the asteroid, and we divide this by 2. And if this condition is met, then we will call the entity's object and remove the missile, and then remove the asteroid as well. We add .ok on the end of these two to remove the compiler warnings it would otherwise generate. And that's all we need to do there. We then switch back to main.rs and scroll down to the dispatcher builder. We need to add in a new reference to the missile striker, which is the same as before, just give it the name of the struct, a name in snake case, and an empty list. And we run cargo run to see what the code looks like so far. And it should show you the spaceship. Let's see what happens when you hit the asteroid with a missile. It disappears forever. To remove the compiler warning, we can go back to missile.rs and place an underscore in front of the players variable, and run cargo run to check that this has now happened. And we can see that that has happened. So now we'll go back to game.rs and scroll up to our update function at the top of the file. Underneath the variable declaration for must_reload_world, we're going to add a new variable to store the current player position. But when we create it, we will simply set all of the values to 0.0, as we'll update them later. Inside our scoped area, we're going to add a variable to hold the positions from the ECS as a read storage. Then we will create a for loop and loop through all of the players, even though there's only one, and remember the .join on the end. We then want to set the current player position x and y values to be the same as the player. We ignore the rotation for now because we don't want the rotation of the player to affect the new asteroid being created. Then we scroll down to underneath the if must_reload_world check. And we will create a new variable to check if we need to create an asteroid. The name will be must_create_asteroid and the default is false. Then inside a new scoped area, we get a read storage reference to the asteroids in the world. And we check to see if our count of asteroids is less than 1. And if it is, we set must_create_asteroid equal to true. Immediately after our scoped section, we will check to see if must_create_asteroid is true. And if it is, then we're going to check where the player is and create the new asteroid away from the player. If the current player position.x is greater than the game width over 2, and the current player position.y is less than the game height over 2, then the player is in the top right quadrant. We will reuse the current player position variable and set it to be the top left quadrant, so that the x-coordinate will be the game width over 4. And the y-coordinate will be the height over 4. And we will set the rotation to be 225, meaning it will move towards the corner and not directly towards the player. Underneath this, we will create a call to a new function, which we are about to create, called createAsteroid, and it will take an argument of ECS and the current player position. And we'll create that new function right at the bottom of the file, so we scroll down there. The function is called createAsteroid and takes an argument called ECS of type world and an argument called position of type componentsPosition. Inside this function, we call ECS.createEntity. And that will have a width for the position, which we can simply pass the position supplied to the function. And then we create a renderable. To get the content for this, we'll just copy the information directly from the call to create entity inside the load world function. And finally, we create a component of asteroid with a speed of 2.5 and a rotation speed of 0.5. Finally, we add .build to finalize the component. At this point, we will scroll up to our previous call to create entity, which created the asteroid. And we will replace it with a call to the new function we've just created, passing in the ECS and a new component's position with the values of 400.0, 235.0 and a rotation of 45 degrees. And we will scroll up to the if statement to check on the location of the player. And we'll add in the remainder of the quadrant checks. For simplicity, we'll simply copy and paste in the new code here. It's not necessary to follow along here because we're going to change the way we place asteroids in a future tutorial. First, we add in the else if to check if the player is in the top left. Then we check to see if the player is in the bottom right. And finally the bottom left. And we try cargo run again. And we can see that when we shoot the asteroid, a new one appears, but away from the player. This reduces the likelihood of it colliding with the player immediately after spawning. Join us next time when we will add in the new way of spawning asteroids, making the game progressively harder as we do so, by adding more and more asteroids. Don't forget to subscribe to the channel and turn on notifications so that you'll get notified when the next video is out. For now though, I'll wish you a good day and hope to see you again soon. Bye for now.